Summary of dual nature of matter. When we talk about this topic, you know light. Light can have two nature. One, particle nature, and second, wave nature. Same thing, matter, any matter can have same these two material, particle nature and wave nature. The main topic we have in this chapter related to the particle nature is known as photoelectric effect, also known as PEE. And related to the wave nature, we have de Broglie wave, also known as matter wave. De Broglie wave, or also known as matter wave. So start with the photoelectric effect. In this photoelectric effect, whenever light fall on the metal surface with some energy, example E, some energy will be utilized to electron come out. That is known as work function. And remaining energy will be utilized to move the electron. That is known as kinetic energy. That's why you will say total energy is equal to work function plus maximum kinetic energy. Okay. So we know in presence of light, electron will come out. And this electron come out in presence of light. That's why it is known as photoelectron. But there are other methods also. If we talk about electron emission, how electron is emitted, there are three methods. Because of heat, electron can come out thermionic, thermionic in presence of heat. In case of strong field field emission means we are talking about electric field, strong electric fields. And last, photoelectric emission in presence of light. So when you emit electron in presence of light, you need minimum energy. That minimum energy is known as work function, represented by this minimum energy and loosely bound electron. It depends only on the surface of the matter. For a given surface, work function value remains same. Okay. If you have energy less than the work function, then photoelectric effect will not occur. Okay. Photoelectric effect will not occur. In this energy, we can say that energy should be more than work function to happen photoelectric effect. Okay. Here we have two concepts when we have energy. One is quantitative, quantity. In quantity, we discuss about the intensity of light. And when it comes to the quality, then we discuss about the frequency. Okay. Intensity of light decide the amount of current. More intensity, more current. And frequency decide the you can say stopping potential. If anybody asks what is stopping potential, it is the negative potential where current become zero. Negative potential where current become zero is known as stopping potential. It does not depend upon the intensity but depend upon frequency of light. You can say intensity independent. So we know energy is equal to NH nu. N is the number of photon, also equal to NHC by lambda. So the minimum frequency we need to eject electron is known as cutoff frequency or threshold frequency. and the maximum wavelength lambda is known as threshold wavelength. Okay. When we know energy was equal to wave function plus maximum kinetic energy. It means if you calculate maximum kinetic energy, energy minus work function, or kinetic energy also is equal to h nu minus h nu naught. Nu naught is the cutoff frequency or threshold frequency. If you correlate kinetic energy and frequency graph, you know your constant is negative. That's why if you make graph of the kinetic energy and frequency, then graph will be like this. It will take negative side, which is equal to h nu naught, and this is theta, and tan theta, your slope value will be equal to h. Same, kinetic energy is also equal to ev naught, h nu naught, nu minus h nu naught. So your stopping potential will be he nu minus he nu naught. Okay. If you make graph of this, again graph look like the kinetic energy graph. But remember, here we have stopping potential relation. So this is stopping potential. Here it is frequency graph. Your slope is in same in the straight line, and y-intercept is negative, which is equal to h nu naught by e this time, and your tan theta will be equal to h upon. Okay. Whenever light fall on the surface, then we calculate radiation pressure, and you know pressure is always equal to pressure P, force by area. So force by area. Force you know is equal to change in linear momentum by time. So force is equal to change in linear momentum by time. How to calculate change in linear momentum? In this case, you should know in case of reflecting surface, perfectly reflecting surface, delta P will be equal to 2P because light will fall on it and it will come into the other side. Both will be equal. In case of perfectly absorbing surface, when surface absorbs the light, delta P will be equal to P because light will hit the surface and then it will be absorbed, no release. That is the important thing. Second, if you check intensity of light, which is represented by I is equal to energy per unit area per unit time. You know energy by time is also equal to power by area. This is the intensity and power and energy relation. Okay. If you talk about the photon are the light quanta, small energy packets, small energy packet. One photon is responsible for release of one electron at a time. Okay. So if you see one photon energy, then one photon energy E will be equal to h nu, depend upon the frequency. If you have multiple photon and photon energy, it will be equal to n h nu. Okay. If you see this photon is electrically neutral, it means no charge. Speed will be speed of light 3 into 10 raised to power 8 meter per second. And if you see mass, how to calculate mass, then you know if you want to calculate mass, mass inversely depends upon the wavelength. Why? E is equal to mc square. So m will be equal to E by c square. And you know E is equal to hc by lambda c square. So it inversely depends upon the wavelength in case of photon. And that explain our basic part of the photoelectric effect. There were some scientists involved in the photoelectric effect. One popular person was Hertz. He took a vacuum tube, and when light fall on UV light fall on the surface, then you know electron will eject out. Then there was a guy Holwoods and Leonard. Holwoods and Leonard. They use zinc screen to see the movement of the electron, photoelectric effect, and this photoelectric effect will be responsible for the photocurrent, and we can absorb observe current with the help of ammeter. Okay, photoelectric effect, everything is done. Last
Sir, can
topic
you
is,
scroll down?
yeah, I'll show you everything in the end. The last part is de Broglie concept or hypothesis, which explain us the matter wave. Matter wave means every particle have both particle nature and wave nature. And in this case, when you talk about the matter wave, these matter wave are neither EM wave, electromagnetic wave, and nor it is mechanical wave. So it is different from both of them. Okay. When you calculate this wavelength, I will write it down. Wavelength. So wavelength will be equal to h upon p, linear momentum, or we know linear momentum is equal to mv, or we also know that p is equal to 2me. In case of energy, 2m, energy is equal to 3 by 2 kBT. 3 by 2 kBT. Okay. Or kinetic energy is also equal to EV naught. Kinetic energy is also equal to EV naught. So it depends what situation is given. You can calculate the wavelength of the particle. Example, if you take electron and you want to calculate the wavelength, put all the mass and charge of the electron, then value will be 22.27 angstrom divided by under root V naught if potential is given. Okay, if you have alpha particle, value will be different because mass and charge will be according to that. Okay, or if you take same thing, it will be under root 150 divided by V naught angstrom. And last part is, if you know according to the Bohr orbit, if you want to see total circumference of any orbit, then circumference you know is equal to 2 pi r, and this 2 pi r is equal to n pi. And this revision is done. Remember, you can do all this stuff only when you know everything about this chapter. Tell me, guys, how much time we took to finish the complete. Did I leave any of the word which was important?
No, sir.
Was I in hurry? Ki I was just trying to complete everything in rush. So now this,
Yes, sir.
yeah, first question: mass m. same energy of photon and electron, you have to calculate their wavelength ratio of de Broglie wavelength. We already did this. In case of photon, you know energy is equal to hc by lambda.
Yes,
So
sir.
lambda will be is equal to hc by 3. If you see, in case of electron, and when you talk about the energy, you know it is equal to h by p or h by under root 2 me. Correct? This is equation 2. They're asking photon by electron ratio. So photon is hc by e and electron is h by under root 2 me.
So it will be
H
C
H
root
cancel.
2m by E.
Yeah. So 2me will be same. If you take this e inside of the under root, it will become e square. It means e square will be cancelled out, and that's why answer will be A. Any doubt, guys?
No, sir. No, sir.
This was NEET 2025 question. Remember this when people say ki paper was really, really, really difficult. Which of the following represent the variation of photoelectric current with proportion to the light? Photoelectric current with proportion to the light in the axis. Correct? So, you know, when you increase the intensity, current will also increase. Correct? When you increase the intensity, photoelectric current will also increase. Correct? So the following correct the
Yes.
variation of photoelectric current with the property of light. First is correct.
Yes, sir.
Huh. Second, intensity of light. This is wrong because with intensity of light, current increase. Correct. Photoelectric current with the frequency not related. And last, this is also wrong. So, what will be your answer? Only A is correct. Done.
Yes.
We did the same graph. This, though we already solved this question. De Broglie wavelength again in n value 2. Very last topic of today's discussion. 2 pi r is equal to n lambda. Correct. We have to calculate lambda value. How to calculate? Lambda value will be equal to 2 pi r by n. Correct. And in the Bohr model, you know radius value is uh, 53 picometer multiplied by n square by z. So it is for hydrogen. That's why z value will be Anvita 1.
1.
N value is given 2. Correct. So put the value of r 2 pi by n instead of r you will write n square by z 53 picometer. So n cancel 2 pi n value 2 z value 1 53 picometer. So it will be 4 pi multiplied by 53 picometer. Understood? Now you are converting into nanometer. So you will divide by 1000. 4 pi multiply 53 divide by 1000. You can convert into the nanometer. Any doubt, guys?
No, sir.
You can get whatever is the value, but this is how it is done. These options are wrong. Chandana, electron and alpha particle accelerate by the same potential difference. V naught value same. If delta theta and delta alpha denote wavelength of electron and alpha particle, which one will be more? You know,
Sir, electron.
wavelength will depend upon h upon p or h upon 2me or h upon 2m e v naught. V naught is same. Can we say wavelength will inversely proportional to the mass and electrons? So if you have more mass, less wavelength. We know alpha particle have more mass, correct? So it will have less wavelength. Anybody have doubt?
No, sir.
Anvita,
No, sir.
next question. Anvita, work function of photosensitive material in electron volt and light of wavelength this is incident with energy above than the threshold value at an instant. Maximum kinetic energy of the photoelectron at that instant will be, what will be your maximum kinetic energy? Energy minus work function,
Hmm. Let's. Hmm. Hmm.
correct? So energy is equal to Hc
Okay,
by
no, no.
lambda minus this, correct? What is the lambda value? Hc by E
Yes, sir.
minus by Hc cancel. Guys, can we say kinetic energy will be
Yes,
E
sir.
minus phi?
Hmm.
Do we have this option? Both of you have any doubt? Anvita, Chandran, any of you have doubt? Yes or no? Am I audible, guys? Hello, hello, hello.
So Chandra is not here.
Okay. So if we say variation of 1 by lambda square and kinetic energy E, what will be the nature of the graph, Anvita?
तो पैराबोलिक ही होगा ना.
Parabola. So we know that h lambda is equal to h upon p or h upon under root 2me, correct? H is constant, mass is constant of any given particle. So if I take square on both sides, lambda square will be is equal to h square by 2me, correct?
Yes, sir.
If you say कि lambda square is inversely proportional to 1 by E, can we say energy will be equal to 1 by lambda square, Anvita?
Yes, sir.
Can we say energy is directly proportional to whole unit 1 by lambda square?
Hmm.
So what will be the graph? How should this graph look like? If you take 1 by lambda square and E, any doubt?
No, sir.
Next question, Anvita. E is the velocity of light in free space. E is equal to h nu. Is this correct?
Yes.
It is correct.
Yeah, correct.
Velocity of photon is speed of light.
Yes, sir.
Yes. Momentum is equal to h nu by c. Like T is equal to E by C. Is this correct? It is correct.
Yeah, yeah. Yes, sir.
In photoelectron collision, both energy as well as momentum remain conserved. This is also correct because
Hmm.
it is perfectly elastic collision. Okay. Photon possess positive charge, no charge on the photon.
Negative. Oh, wait, yeah, no charge.
No charge. No charge
Hmm.
on the photon. Any doubt?
No.
Work function of cesium, potassium, and sodium are given this. If incident electromagnetic radiation have this energy, which of the photosensitive surface may emit photoelectron? Anvita,
1 second, sir. One fraction of. So, like, mm,
to emit photoelectron, do you agree energy should be more than work function?
yes, sir.
If we are saying our incident energy is 2.2, then our work function should be less than this. Only then electron can come out. Any doubt? So whichever element have work function less than 2.2 can emit electron. And if work function is more, we cannot emit electron. So what will be your answer? Only first element. Correct? Only first element, that is cesium. Do you have only option cesium? Yes. Chandana, am I audible? I think she is still facing issue. And with the next question, how to solve this question?
Sir,
Chandana, am I audible?
yes, sir.
Okay, good. So what is the formula for electron
Sir, I was
given?
there only up to fourth question.
It's okay. I will do revision for you. So wavelength of the electron will be 22.27 angstrom divided by under root V naught.
Yeah.
Right? And one
81 is V
na-
naught, right?
1 nanometer is equal to 10 angstrom. So 1 angstrom is equal to 1 by 10 nanometer. So if you multiply by 1 by 10, 1.227 divided by what is the under root of 81? 9.
9.
You can get answer. Any doubt, both of you?
No, sir.
No, sir.
This. What is the answer? D. Chandana, next question. Maximum kinetic energy of emitted photoelectron is independent of. Maximum kinetic energy is independent of intensity of the incident
Yes,
radiation.
sir. Intense.
You know kinetic energy is equal to energy minus work function. So we know work function will decide the amount of kinetic energy. Second, we know frequency of incident light. The energy is equal to h nu minus phi. So nu will decide the kinetic energy. This is also correct. Correct. Wavelength of the incident radiation. This is will be equal to c by lambda minus. Wavelength will also decide, but intensity too. Both kinetic energy as well as stopping potential is independent of intensity. Understood?
Yes, sir.
We can add this in our notes. Kinetic energy as well as stopping potential both are independent of intensity of light. Even I will include one more thing, frequency also. Okay, so all are independent of intensity of light. Anvita, next. Light ray have uh, photon energy this. Falling on metal surface work function this. What is this stopping potential?
Right. That K max from K, yeah, this one only.
Tell me your answer. E value is 4.2 electron volt minus work function is 2.2 electron volt.
Yes, we get 2.
Electron volt E cancel. Any doubt? Any doubt, guys?
No, sir.
Yes, sir.
Chandana, next question. Threshold frequency is this. If light have uh, frequency this incident on the metal, what will be the maximum kinetic energy emitted?
So 3.
It is energy minus work function. Kinetic energy will be h nu minus h nu naught. Correct?
Yes, sir.
Kinetic energy. What is h nu value? H 4 nu naught minus
Yes,
h nu naught. What will be the value?
3 HP.
3 h nu naught. This spelling mistake, but it will be 3 h nu naught. Any doubt?
No, sir.
Anvita, if you see the graph of wavelength and linear momentum, what will be the relation?
Second, what's the formula? H by P, no?
Lambda is equal to h by p. So lambda inversely
And
proportional
also
to p.
proportional to P. So,
How will be the graph look like?
like a reversed parabola.
Parabola. Correct? Parabola.
Hmm.
Chandana, next question. Two monochromatic light, one have frequency this, second have frequency this, incident on the metal surface. This stopping potential is this and this. What is the threshold frequency of this metal? kinetic energy is equal to E minus wave function h nu minus wave function. Remember, for a given matter, wave function remains same. For a given matter, wave function remains same. Okay, so kinetic energy is also equal to E V naught. Right? In first situation, when frequency is new, then stopping potential will be this E. Was the stopping potential? By 2. When what is the new value? Equation 1. Any doubt, guys?
No, sir.
I put this value for the stopping potential, this value for the frequency. First one. Second one, what is the stopping potential? Vs. H. What is the frequency? Equation 2. Correct. If you have to calculate threshold frequency, you know stopping potential will be equal to h nu naught. You have to calculate stopping. So what you can do is instead of wave function, you can write h upon nu naught or h common nu minus nu naught. Same here. If you are doing this equation, this is h nu naught, h common nu by 2. And if you take both of this equation and divide one by other, what will happen? E cancel out, Vs cancel out, H cancel. Any doubt, guys?
No,
So
sir.
1 by 2 will be equal to nu minus nu naught, nu by 2 minus nu naught. Cross multiply. Any doubt, both of you?
No, sir.
Just take another side. 2 nu naught minus nu naught. It will be 2 nu minus nu by 2. So it is nu naught. And this is, tell me, guys, what you need to take first, writing this equation, and even you can extend this equation and h nu naught. Take this equation. And when you take this equation, just put values and you will get answer. You have to put value 2 times and take their ratio. Things will be easy. Understood?
Yes, sir.
Anvita. Number of photon
Sir,
per second on an average emitted by the source of wavelength into 10 raised to power minus 9 meter, and power is equal to. So what is the relation? You know power is equal to energy by time. Energy is equal to N
energy, right? For
hc by lambda. This is energy. By
yeah.
time, you have to calculate N by T. Take hc by lambda to the another side. N by T is equal to P lambda divided by hc. Correct? You know 1 nanometer is equal to 10 angstrom. Can we say 600 nanometer will be equal to 6000 angstrom? correct? P value, lambda value 6000 angstrom, Hc value 12,400 almost. 2020 cancel. 6 can you put from you can divide from 2, 3 2 is 6, this 3 4 is okay. So it is 6.6 by 41 into 10 raised to power minus 3. And remember, this is in electron volt. So you have to take 1 electron volt is equal to 1.6 into 10 raised to power minus 19. 1.6 into 10 raised to power minus 19. You have to get approx value. So don't do exact calculation. Approximately 4. Approximately 10. Okay. 10 raised to power minus 18. It will go up. Tell me, I messed it up or you understood everything?
Understood, sir. But can you scroll down? I can't see the last line.
You can't see last?
Yeah, I don't know why I can't. Okay, now I can.
So do check and do calculation properly. And same thing you can do the exact calculation. Maybe if we do exact calculation for the same thing, you will get exact answer because I didn't get. Let me check. N by T is equal to P lambda by Hc. What is P value? 3.3 into 10 raised to power minus 3. Lambda value 6 into 10 raised to power minus 7 by H value 6.6 into 10 raised to power minus 34 and C value 3 into 10 raised to power 8. Why I am doing this? Easy calculation. Understood? Easy calculation. Here above it is 10 raised to power minus 10. Below it is 10 raised to power minus 26. Was it easy to do? Because here calculation is way easier. You have to just put values. Understood?
Yes, sir. But after this, I don't think so I will understand anything.
We will do last question. There. Chandana. This one. Correct. What is the wavelength value? Nanometer. If you multiply this, it will be 10 angstrom, means 1 nanometer, right? 10 angstrom is equal to 1 nanometer. Nanometer will be cancelled out. Okay. So 1 by under root V is equal to 10 raised to power minus 2. If you take 1 by V, you do square, what will be V value? Tell me. Make sense?
Yes.
Just formula. This Tell me, both of you, Chandana and Anvita, how would you rate this chapter? Easy, medium, tough?
So easy only. Only few things, like few questions confusing, otherwise it's fine.
Yeah. Chandana,
Yes, sir. If we revise properly, it will be easy.
it will be easy. That's the point. Okay. So revise properly, solve more number of questions. We discuss almost every kind of question, and that is why now you can solve any question from this chapter because we finished all the variety of the subject.